In this video for section 3.2, we're going to introduce a new concept called the multiplicity of a zero. So in sections 1.5 and 1.6, we talked about how to solve a polynomial function by factoring, setting each factor equal to 0, and solving. And this gives us the x-intercepts, which are also called the zeros on the graph. The multiplicity of a zero is the power of the factor that results in that zero. So the important thing to remember when you're looking for the multiplicity is that it's the power or the exponent on that factor or on that set of parentheses. And the multiplicity tells us what the graph looks like at that zero. So if the multiplicity of a zero is an even number, then the graph touches the x-axis and turns around at that zero. So for example, if this is my zero, then the graph might look like this. Touches the x-axis and turns around. If the zero is an odd multiplicity, then the graph crosses the x-axis at that zero. So if this is my zero, and then the graph is going to cross from one side of the x-axis to the other. So we're going to look first at example 7. It says to find the zeros of f of x equals 1/2 times x plus 1 times 2x minus 3 squared, and give the multiplicity of each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. So our factors here that have variables in them are x plus 1 and 2x minus 3. The 1/2 does not have an x with it, and so that's not going to be something that I need to set equal to 0 and solve for x because there is no x. So we're going to start with the x plus 1, set that equal to 0, and solve by subtracting 1 from both sides. That gives me x equals -1. So that's 1, 0. The other one is 2x minus 3. So set that equal to 0 and solve. I need to add 3 to both sides. And lastly, divide by 2, and we get x equals 3/2. So those are my two zeros. Now, I'm going to write this out the way that you're going to see it in the homework. The first question it's going to ask you is to fill in the zeros. So the zeros here are -1 and 3/2. So you would separate those with a comma. And then the second thing is that they're going to have multiple choice, and first you're going to identify how many zeros there are. So there are 2 zeros, -1 and 3/2, and then it's going to ask you for the multiplicity of the largest zero. So I need to identify which of these two numbers is larger. That's going to be 3/2. Now, for the multiplicity of 3/2, I go back to my original problem and find the set of parentheses that led to that answer, and that's 2x minus 3. The exponent on that set of parentheses is 2. So the multiplicity of the largest zero is 2. The multiplicity of the smallest zero so the smaller number is -1. Go back to that set of parentheses that led to the -1, and the power on that set of parentheses is 1. If there is no power, it's an automatic 1. So the multiplicity of the smallest zero is 1. And then the last part of the question is it's going to ask you what the graph does. And so going up here, we know that if the multiplicity is even, then the graph touches and turns around at that 0. If the multiplicity is an odd number, then the graph crosses at that 0. So the graph crosses at the 0 that has the odd number for the multiplicity. The odd number for the multiplicity is at the smaller 0, which is -1. So that means the graph crosses at -1 and touches and turns around So it touches and turns around if the 0 has even multiplicity. 2 is an even number, so the larger 0, or at 3/2, is where it's going to touch and turn around. And so they might, both zeros might be crossing, they might both be touching and turning around. It just depends on what the graph looks like. So I would fill that in the boxes in the homework. So next you should try checkpoint problem number 7. Do this in your notes, check your answer, and then move on with the video. Okay, we're going to do a couple more problems here to practice this, and we're going to start with exercise 29. This is one of the homework problems, and you'll see something similar in your homework assignment. So it says to find the zeros, and this time the problem isn't already factored. So I need to do that first in order to find the zeros. So what I have here is f of x equals x to the third minus 2x squared plus x. So remember, when we're factoring, the first step is always to look for a GCF. In this case, I can take out a factor of x. So I would take that out to the outside. That's going to leave me with x squared minus 2x plus 1. And then I would try to factor this set of parentheses. This is a trinomial, no number in front of x squared, looking for two numbers that multiply to +1 and add to -2. Well, that's going to be -1 and -1. So this is going to be x minus 1 times x minus 1. And then what we're going to want to do to help us find the multiplicities is write the x minus 1 as x minus 1 squared instead of x minus 1 times x minus 1. And so that tells me that that's a power of 2. So this is my polynomial in factored form. Set each factor equal to 0. So we're going to have one that's just x equals 0 from this x, and then the other one is x minus 1 equals 0. So that gives me x equals 1. So these zeros are 0 and 1. There are two zeros. The multiplicity of the largest So 1 is a larger number than 0. So the multiplicity of the 1 is 2, because the 1 comes from this factor, and this factor has a power of 2. So the multiplicity of the largest 0 is 2. The multiplicity of the smallest 0 So the smaller 0 is 1, or is 0. Sorry, 0 is smaller than 1, so 0 is the smallest 0. And the x that led to that 0 doesn't have an exponent, so it's an automatic power of 1. So the multiplicity is 1. And then what does that tell us about the graph? The graph crosses the x-axis at any 0 that's multiplicity is an odd number. The multiplicity of the smallest 0 is 1, the smaller 0 is 0, and so the graph crosses the x-axis at 0. where does the graph touch the x-axis and turn around? Well, that happens at a 0 of even multiplicity. 2 is an even number, so the larger 0 has even multiplicity. 1 has an even multiplicity, so that means the graph touches the x-axis and turns around there. So it touches the x-axis and turns around at 1. Lastly, we're going to look at exercise 31. Same thing, we have to factor this first, and then we can determine the multiplicities of the 0 and then state what the graph does at those multiplicities. So my function here is x to the third plus 7x squared minus 4x minus 28. Now this problem is going to be something that I factor using grouping. So split into two groups, factor out x squared from the first pair, and that leaves x plus 7, minus 4 from the second pair, also with x plus 7. And then we have two factors of x squared minus 4 and x plus 7. Now x squared minus 4, that I can factor again. That's a difference of two squares. Square root of 4 is 2, and so this would factor into x minus 2 times x plus 2. And then we also have the x plus 7, so bring that down as well. So those are my three factors. Set each one equal to 0 and solve. We get x equals 2. We get x equals negative 2. And we get x equals negative 7. So in this case, there are 3 zeros. The zeros are, start with that, 2, negative 2, negative 7. Doesn't matter what order I put them in. So there are 3 zeros. Multiplicity of largest, I'm going to abbreviate here so I don't run out of space. Now, for this, each set of parentheses has a power of 1 because none of them have any powers on them. So they all have a multiplicity of 1. So multiplicity of the largest 0 is 1. Multiplicity of the smallest 0 is 1. And the multiplicity of the other one, the middle one, is also 1. They all have a multiplicity of 1. And so what that means about the graph is that at each of these points, the graph crosses the x-axis. So it's going to cross the x-axis at 2, negative 2, and negative 7. So next you should try to do the homework problems for this section.